The Platonic solids are the three-dimensional regular geometric solids which are composed of the two-dimensional congruent regular polygons which we studied in class. They are mentioned in Lesson 1-7 of our textbook. There is much information on these solids because they have been known and studied since about 2000 BC. This presentation will briefly discuss their properties, discovery, history, and occurrence in art, nature, science, and life. A Platonic solid is a special type of polyhedron. In Greek, poly means many and hedron means faces. A polyhedron is a three-dimensional figure with faces that are polygons. Platonic solids are unique because all the faces are congruent regular polygons. All the edges are congruent. All the vertex angles, the interior angles of the faces, are congruent. All the dihedral angles, the interior angles formed by two adjacent faces and a common edge, are congruent. Consequently, Platonic solids are the only polyhedrons that are symmetric in 3 dimensions. There are exactly 5 Platonic solids possible in 3-dimensional space. Their names are based on the number of faces. The regular tetrahedron is composed of 4 congruent equilateral triangles as faces. The cube, or regular hexahedron, is composed of 6 congruent squares as faces. The regular octahedron is composed of 8 congruent equilateral triangles as faces. The regular dodecahedron is composed of 12 congruent regular pentagons as faces. The regular icosahedron is composed of 20 congruent equilateral triangles as faces. The simplest geometric proof that there are only 5 Platonic solids is based on vertex angles. To create a 3D polyhedron, at least 3 polygon faces must meet at each vertex. To maintain a 3D polyhedron shape at each vertex, the sum of the vertex angles must be less than 360 degrees, because at 360 degrees the polygons would lie flat in a 2D plane. 3 congruent equilateral triangles have a total vertex angle of 180 degrees, which forms a regular tetrahedron. 4 congruent equilateral triangles have a total vertex angle of 240 degrees, which forms a regular octahedron. 5 congruent equilateral triangles have a total vertex angle of 300 degrees, which forms a regular icosahedron. Three congruent squares have a total vertex of 270 degrees, which forms a cube. 3 congruent regular pentagons have a total vertex angle of 324 degrees, which forms a regular dodecahedron. 3 congruent regular hexagons have a total vertex angle of 360 degrees, which does not work since the hexagons would lie flat. Therefore, there are only 5 possible Platonic solids. The basic geometry data and surface area and volume formulas for the Platonic solids are presented in the next 5 slides. Each slide contains a 3D picture of the solid and a 2D diagram of the unfolded faces. The 2D diagram could be cut out of paper and folded on the common edges to create a 3D solid. Note that due to the symmetry of the solids, all surface areas and volumes can be calculated if you know only the edge length noted by the letter S. The regular tetrahedron is the simplest solid with 4 congruent equilateral triangles as faces. When all solids are constructed with the same edge length, it is in 5th place with the smallest surface area and volume. The cube, or regular hexahedron, is the second simplest solid with 6 congruent squares as faces. It is in 3rd place with regard to surface area and volume. The regular octahedron is the 3rd simplest solid with 8 congruent equilateral triangles as faces. It is in 4th place with regard to surface area and volume. The regular dodecahedron is the 4th simplest solid with 12 congruent regular pentagons as faces. It is in 1st place with regard to surface area and volume. The regular icosahedron is the fifth simplest solid with 20 congruent equilateral triangles as faces. It is in second place with regard to surface area and volume. Although these 5 unique regular polyhedrons are referred to as Platonic solids, they were known at least 1500 years before Plato. Their discovery and history are very interesting. Carved stones similar in shape to these 5 solids dating from about 2000 BC were discovered in Scotland. They are now in a museum at the University of Oxford. The Egyptians were aware of the cube and the tetrahedron when the pyramids were built. Many pyramids have the same shape as the top half of an octahedron. Pythagoras and his followers were also aware of the dodecahedron. Theaetetus, a friend of Plato's, added the octahedron and icosahedron and is thought to have written the first complete description of all 5 solids. Euclid concluded his book Elements, which is a basis of Euclidean geometry, with constructions and descriptions of all the solids. Empedocles believed that the earth was composed of 4 basic elements: earth, fire, air, and water. Plato's book Timaeus is a discussion of the composition of the physical world. He believed that these 4 elements had the geometric form and properties of the solids. Consequently, the solids became known as the Platonic solids. Plato related the cube to earth, the most immobile and unchangeable element. The tetrahedron was related to fire, the most mobile and least stable element. The octahedron was related to air, the intermediately mobile and stable element. The icosahedron was related to water, the least mobile and most stable element. The dodecahedron was related to the entire universe for reasons that are not clearly stated. Although Plato's theory relating the solids to the composition of the earth and universe was wrong, his careful thought and reasoning helped advance the scientific method of discovery. During the Renaissance, the Platonic solids were used in art and science. Leonardo da Vinci provided illustrations of these solids for artist Pacioli's 1509 book, The Divine Proportion. The artist Albrecht Dürer often included geometry and solids in his work. Johannes Kepler's Platonic solids model of the solar system from his 1596 book, The Cosmic Mystery, used as a nested set of different sizes of the 5 solids. An inscribed sphere for each solid represented the circular orbit of each known planet. The circumscribed sphere and the largest solid represented the entire universe. Kepler's orbit theory was incorrect, but like Plato, his works advanced the scientific method. In modern times, Platonic solids may be found in art, sculptures, drawings, paintings, and architecture. The famous 20th century artist M.C. Escher used geometry and the solids frequently in his work. Platonic solids are also found in nature. Minerals such as iron pyrite and fluorite, table salt, and diamonds have naturally occurring crystal forms such as cubes, octahedrons, and dodecahedrons. Due to the nature of the chemical bonding angles of elements such as carbon and hydrogen, there are some chemical molecules that closely resemble Platonic solids. A methane molecule is shaped like a tetrahedron. A cubane molecule is shaped like a cube. A dodecahedron molecule is shaped like a dodecahedron. Some very small life forms of biology also resemble Platonic solids. Viruses can be shaped like an icosahedron. Various types of amoebic sea life, such as the radiolarian family, are shaped like all 5 of the solids. From ancient times to today, the Platonic solids continue to be very evident in geometry, art, nature, and life. They are a source of beauty and the philosophical thought for us.